The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. In a previous episode, we began working on an automatic puppet head whose jaw would move in sync with voice. In today's episode, we're going to finish it by following these steps. We're going to mod the troll puppet, which is the actual puppet they want to use anyway, to have more room into his head for the jaw and other mechanism that we need to add. So basically, instead of trying to make something that goes up into a puppet, we're just gonna build it right in the puppet's head to start. Then we're gonna convert the breadboard circuit that we made onto a PCB and add trim pots and make it all nice and put modular plugs on it. We need to add one more circuit, which will take the square wave, the on or off voice wave that we have already, and subdivide that back into pulses, because if we use a coil, we don't want to overdrive it. We want to actually hit it with smaller pulses so it won't get as hot. Then we're going to wire up a high-powered, high-speed coil. So we need to take like a 24-volt power supply and like hit that coil really fast. We need a lot of speed and power to move the jaw, so I think a solenoid electromagnet is the best way to go. Finally, we're going to reassemble everything into the puppet head and test it out. Let's get started.
Amazing builds, exclusive mods, cutting-edge ideas, electronics, engineering, and more. Every week on Element 14's The Ben Heck Show.
This puppet is the target of the project. He is the internet troll. He has a blog and he types on the computer, so he's got glove hands that actually have human hands inside of them. But they want him to talk live, so as you talk, he talks, but automatically, so you don't have to think about how to do it. Frank Oz would probably be like, I know how to do that. But we're not all Frank Oz, so if we can use computers, that's better. And this puppet is a little different from the others, whereas the neck is connected to the puppet body, which causes more strain. So this guy's already kind of coming apart a little bit. So we've been given the go-ahead to crack open this guy's skull and build the mechanics into his mouth, because they don't need it until the summer. And hopefully we can do it by then. All right, so you ready for your brain surgery? No! Your troll wife signed the consent form. I should have never married her. Well, you should have thought of that before you gave her power of attorney. Drat! Breathe deeply. No. Time to operate. Don't worry, troll. I'm using a brand new X-Acto knife, which means your life is worth at least 68 cents to me. I'm actually cutting the threads, not the fabric, just so I can do this as non-destructively as possible. Luckily, a lot of these things are literally hanging by a thread. You don't really get to use that term literally very often, but today I did. Achievement unlocked. Now I just gotta achieve my other goals. So my goals in life, I have, 4? Make a country western album, go to space, do a voice in an animated movie, and that's it. I guess I only have 3. I still haven't achieved them yet, just throwing it all away. I'm thinking we either take this or we make another version of it, and that will attach to the upper lip and basically stay put. And then we have that as our base, and then we move the jaw against it. And we could open up his mouth here and actually drive screws up into it and just use black screws so you can't see. So what we were trying before was to put this claw thing into the mouth. But it was kind of tricky because we were making something that could insert into the puppet. And it still had to, be removable and other things. See, when you can actually get up inside of it, you can do a much better job of putting it where it needs to go when you basically can see what's going on. David Bowie, why have you betrayed me? Oh my, he's dead. I'm Jennifer Connelly. I've changed my jaw design since the previous episode. I'm going to build something right into the puppet head, and I also took measurements to account for the thickness of the cardboard that was used for the jaw, the distance between the pieces, everything. That's what I came up with. This is a side view. This will be the bottom jaw here and the top jaw. The top jaw will also hold the coil, which will actuate everything. So the coil will sit right in here. There's a slit for it. We have a large portion here so that it can, not break. It'll have some good solid surfaces. Let's look at the next part, which is going to be the lower jaw. This part's really simple. it has a little lip on it right here, and that's what's actually gonna push up against the cardboard. So everything here will fit into the jaw with a known parameter. Specifically, it'll butt right up to the cardboard that's already in there. We have a slit here, so there will be a piece that fits in that slit and then is sucked up into the coil. We also have the jaw mount. You can kind of see the past portions here. So this portion will fit around the upper jaw piece, and we'll just glue it in place using acetone. And we have enough room back here for the coil. And then in the bottom, we have some countersunk portions where we can stick 2 half-inch pieces of PVC pipe to create the neck and backbone of the puppet. Let's get these printed out and assemble them. We've completed the surgery on the troll puppet. This is the one we're actually trying to automate. I've done a few things differently with the jaw. I made this multi-piece upper jaw, and I think we can get better action by putting the actuator up here. And I have some PVC pipe that can act as a base. So we've got 2 of them. That'll make it a little bit more rigid. All right, so those fit, that's good. I've also glued this whole thing together with acetone and coated it with acetone to increase its strength. What a shock, I have tons of these pinball solenoids laying around. So what a solenoid does, at least in this case, is it's an electromagnet and it pulls metal toward its center. So even if you just had a loose metal rod and activated the solenoid, it wouldn't shoot out the end, it's just pulled center like that. And then whatever direction it's not in, it's pulled in that direction. So what you usually do is you have a little bit of it in and then it's pulled into it. That's how all solenoids work. So we're gonna use this because it'll be a really fast action, although we wanna use the proper voltage so it doesn't overheat. And I've cut quite a cavity around it so it won't touch any foam or whatever. We'll see how it performs. We need the sleeve, there we go. Yeah. As opposed to the first jaw that I made, I actually drew this cardboard jaw in the computer, so I had a really good idea of the relationship between the pieces, their spacing and everything. And this jaw reflects that. So it actually allows it to hinge where it hinges in there instead of where it wants it to hinge, if that makes any sense. So here's the rod, and it has a triangular piece of Bakelite on it. It's funny they still use Bakelite for stuff. Bakelite was like the first composite material. You could call it the first plastic. Old radios from the 30s that you've probably seen, that's all made out of Bakelite. So here's the jaw, it's gonna look like this. And the spring will push it down as a default, but when it sucks up because of the electromagnet, that's what should open the jaw. So I'm going to install the upper jaw first and then the lower jaw, and hopefully we can make the mouth move. We have a button here for easy testing. I'm gonna use hot glue to secure this in place, but I have to make my move quick. All right. I'm going to use the 2 screw holes inside the upper lip to attach this piece. I'm going to drill through them and then attach screws. That should hit the plastic assembly. I can feel it go through, that's good. The thing to look for is what color material came back on your bit. That's how you know what you hit. If it rhymes, it must be true. Oh, we're pretty close to being able to test to see if this actually works. I'm not excited, but I'm interested to see if it works. I actually never get excited about anything, except maybe that brownie in Austin. So the lower jaw goes here, and then the steel rod goes up into the solenoid, and then we have little lips here, so we know what the relationship between the jaw and the cardboard is. That's how I designed it on the computer, and that's how it needs to go together. I even drew in the difference. See how this cardboard's a little bit below this one? I even drew that in just to make sure that we had a very accurate model. All right, so I've got to basically just do this in one shot. I'm gonna pull the spring back and then stick the jaw in. Here we go. Down by the riverside has got to be a better ride than what you have planned. Carry your heart in your hand. Why do I have that song in my head now? You use a lock nut here, so it's all good. The spring on the solenoid pushes down on the rod, which pushes up on the jaw. So you have a really good spring action, and the jaw closes fully. That's good. I guess we can try to make him talk, I'll plug in this power supply and we'll see what happens. There we go. Well, it looks like the jaw opens the way we want. It's definitely semiconducting, which is Ben Heck speak for it's getting warm. It's actually not too bad. All right, it works mechanically, so I'm going to go ahead and secure the jaws a little bit better, and then we can move on to the next part. Now it's time for a tech timeout. We're always looking for ways to improve the new shop. Felix built this rack to hold all of the 3D printer material. So it's right here where the printer is. Very handy. Plus, as an added bonus, it looks more interesting in the background of the shots that we film than a bare white wall does. See, we got this whole wall pretty much filled up now. That was on purpose. I've hooked up a monostable multi-vibrator timer to my circuit, and what it is doing is taking the low edge pulse coming off of my voice and extending it. So a little pulse of my voice gives a minimum of 4 milliseconds of on time. This is so we can take the high frequency waveforms of voice and smooth them out into something more mechanical and simple like an on-off mouth. I'm using about 3 mega ohms resistance on the timer, and that gives us a pretty good result. See how the light is basically going on and off as I talk, and that will be used to trigger the jaw. Let's take a look at it on the scope. I'll run it here. Hi, I am the internet troll. Stop. Here is a close-up of one word from my phrase. We can see the individual square waves coming off of my voice where it goes low from the op amp. And here, this green line going from low to high, that is the output of the timer. If it sees any high to low, edge detection, it will go high. Basically, it's invert. We can use that to drive the jaw. So even though that particular word is made of a bunch of different waves and, oscillations in my voice, it comes off as one solid on-off pulse. So we're basically taking all the nuances of the voice and boiling it down to, am I talking or not? I'm using this particular timer because it allows easy re-triggering. You can't always re-trigger so easily on a 555, like it always has a timeout before you can re-trigger it again. This particular timer is meant to be re-triggerable. What I'm gonna do next is take this sloppy breadboard and wire it up on a PCB so it's nice and neat. Now that I know the breadboard version of the circuit works, I can transfer it onto a PCB for permanent usage. I'm going to add things such as jacks to plug in power, microphone, etc., and potentiometers to allow us to adjust things on the fly, namely the gain of the microphone and the level at which the microphone will trigger the circuit to actuate the jaw. The output of the op amps is going to go to a timer, which will turn the minimum pulse width of my voice modulations into a more solid signal, turning the waves of my voice into solid on-off states that will represent words. Words like this, more or less. We will also add plugs for power input, solenoid power input, and jaw output. It's time to finish the electronics that will allow us to drive the puppet head. Here is a PCB version of the breadboard from the previous episode. So that works well. However, as we mentioned with the solenoid, we want to kind of subdivide that again. This would work, it'd like turn the solenoid on and off with my voice, but we don't want to overheat the solenoid, so we're going to pulse it. So ironically, we've gone from pulses to squares, back to pulses again, but we want to control the pulses going into the solenoid. Let's turn this off. And what I want to add is a 555 square wave generator, which Felix has breadboarded for us here. Felix is always, getting circuits ready behind the scenes in order to speed things up on the show. It's very nice of him. Okay, so let's power this one on. Over here on the scope, you can see the pulse coming out of it. And I want it to be about, 1,000 hertz. And there's an adjustment pot. What I want to do though is make the pulse as short as possible and use the minimum energy in order to pulse the coil. So when we hook this up to the jaw, we can start with this and then increase it just until there's enough force or enough pulses to cause the jaw to open. That will give us the most efficient use of power and also the least amount of heat. So there's going to be two things in this circuit. There's the blinking LED voice and the 555 pulse generator. We're going to put both of those into an AND gate. So the pulses will always be happening, but if the AND gate doesn't have both inputs, it won't matter. So if your voice is activated the LED and the pulse is active, then you'll get an output from this AND gate, and that's what will actually drive the solenoid. We'll drive the solenoid using a IRL 530 logic level MOSFET. We don't want to send straight on-off pulses to the jaw, so I am adding a 555 timer that will take the on-off pulses from the other timer and subdivide it into 1000 Hertz pulses so the solenoid will not overheat. We have 3 total adjustments on this at the moment. We have microphone gain, trigger level for the voice, and then the last one is the pulse width for pulsing the coil. I have 2 different power supplies to try. I have a 48 volt and a 24 volt. The 24 volt is sufficient to activate this coil. However, the pulses might not be long enough, so we might need to adjust the circuit. But just for now, we can test it using the 50 volt supply, which has a better chance of success. All right, I'm going to start with the minimum pulse width. 50 volts is a lot to put through anything. Every time I talk, you'll see the LED blink, but his mouth isn't moving because the pulses are too short. Let's increase the pulses. Hello? Hello? It's starting to work. Hello? I have life! Where am I? Who am I? You will never escape the labyrinth, Jennifer Connelly. Forget about the baby. Okay. So we want the mouth to open fully, but we also don't want the coil to overheat. I'm gonna lower it. Hello? 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 Oh, hi there, babe. Yeah, it's getting warm. I think the trick is to use a 24 volt supply. That might be safer. All right, we now have a 24 volt power supply. Hello? 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 I'm pretty sure the 24 volt power supply can actuate this jaw. I just think we need to change the timing. I'm just gonna hit it with power directly. Clearly the safest thing I can possibly do. Ha ha ha. Watch, I'll probably jump when this thing sparks. Yeah, it definitely can get there. Okay. I think I just need to adjust the timing on the circuit a little bit to allow for the 24 volt coil to do its job. We're going to need to bring in a puppet specialist in order to put this thing back together. In the meantime, I'll get it ready by wrapping the coil with some Kapton tape and also making sure the screws inside of his mouth are painted black. We got the puppet back from the seamstress all in one piece. Let's hook him up and see what he can do.
It's so hard to navigate this maze.
It's called a labyrinth, thank you very much.
Oh, labyrinth, schmabyrinth. I'm looking for my baby brother. Have you seen him?
You can forget about the baby. He's long gone with Jared, the Goblin King / punk rock singer.
Oh, but how could I possibly forget my baby brother? Do you know where he is?
He's at the center of this. We actually don't even like the term labyrinth anymore. We prefer linearly challenged structure. Anyway, your baby brother, whom you should just forget about, is at the center of it.
Have you seen the Hulk anywhere? The Ang Lee version.
Oh, the one where Nick Nolte becomes a Hulk god? Can you explain that to me, please?
I don't think anyone can.
For this project, we took on the challenge of automating a puppet's jaw to move automatically when a person speaks. The mechanical part of the jaw took a few attempts. The circuit to control it required a lot of testing, but in the end, the project worked really well. The only thing I'd do differently in the future is to design the entire puppet's head from scratch to give it the best animation possibilities. What would you have done differently in this build? Have you ever built movie props or special effect devices before? Let us know what you did on the Element 14 community, where you can also keep track of our upcoming episodes, builds, and special events. We'll see you next time. Mr. Lucas, what are your plans for the Star Wars prequels? I'm going to take a bunch of excellent actors and make them completely suck.
I'm Jennifer Connelly.
Never build anything you can't take apart. This is a Ben Muppet, a Buppet. So do you have to be a Muppet to be a Muppet, or is any puppet made by Jim Henson a Muppet? Think about this. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.